Have you ever wondered why we happily eat cows, chickens, deer, and fish, but almost never lions, wolves, foxes, or even seagulls? Is there something about these animals that makes them poisonous? The short answer is no. Most of them are perfectly edible. So why aren't they on the menu? Let's break it down. First, let's get one misconception out of the way. You can eat a lion. People have eaten lions, bears, crocodiles, and even seagulls throughout history. They're not inherently toxic. The real question isn't can you eat them? It's why don't we? One reason is practicality. Imagine you're a hunter thousands of years ago. Would you rather spend your energy chasing a dangerous lion or hunt an antelope? The antelope gives you more meat, tastes better to most people, and is far less likely to kill you in the process. From an evolutionary standpoint, hunting predators simply wasn't worth the risk. But there's another reason that's even more interesting: disease. Predators sit at the top of the food chain, and that matters. Let's imagine a rabbit spends its entire life eating grass. The grass contains tiny amounts of pollutants from the environment, not enough to harm the rabbit. Now imagine a fox eats hundreds of rabbits during its lifetime. Every rabbit contributes a tiny amount of those pollutants. The fox stores them in its body. Then imagine an even larger predator eating many foxes over its life. The concentration gets even higher. This process is called biomagnification. Some substances, like mercury, certain pesticides, and industrial chemicals, aren't easily broken down or removed by the body. Instead, they accumulate. As you move up the food chain, predators often end up carrying much higher concentrations than the animals below them. The same idea applies in the ocean. Tiny organisms absorb trace amounts of mercury. Small fish eat them. Bigger fish eat hundreds of small fish. Then tuna eat those fish. By the time you get to a large predator like a bluefin tuna, the mercury concentration can be many times higher than it was at the bottom of the food chain. That's why health authorities recommend limiting consumption of some large tuna species, especially for pregnant women. But toxins aren't the only concern. There's also parasites. Think about it this way. A rabbit only has to avoid parasites from its environment. A fox, however, eats hundreds of rabbits. Every single meal is another opportunity to ingest parasites. Over years of hunting, those chances add up. That's why carnivores and scavengers are generally more likely to carry parasites that can infect humans. One well-known example is Trichinella, a parasite found in wild carnivorous mammals and some omnivores, including bears and wild boar. If infected meat isn't cooked thoroughly, it can make people seriously ill. So does that mean we should never eat predators? Not at all. People in places like Alaska, Canada, and Scandinavia regularly hunt and eat bears. The meat just has to be prepared carefully and cooked thoroughly. So what about sushi? If large predators are risky, why do people eat raw tuna? That's a great question. And yes, there is a risk. Wild tuna can carry parasites, and large tuna species can contain significant amounts of mercury. The difference is that sushi-grade fish is handled under very strict conditions. Fish intended for raw consumption is typically frozen to temperatures that kill parasites before it's served. It's also kept under carefully controlled refrigeration and hygiene standards throughout the supply chain. That dramatically reduces the risk. Notice that this doesn't remove mercury. Freezing kills parasites. It doesn't remove heavy metals. That's why choosing the species of tuna still matters. So in the end, humans don't avoid lions because they're inedible. We avoid them because they're inefficient to hunt, often protected by law today, can carry more parasites and, as apex predators, may accumulate higher levels of certain toxins. Meanwhile, herbivores like deer, cows, goats, and sheep provide more meat, are easier to obtain, and generally pose fewer health risks. Sometimes the simplest explanation is the correct one. Nature has already done the cost-benefit analysis for us, and after thousands of years, we decided the antelope was a much better dinner than the lion.